Hey everybody, BTO Pro here. We're going to take our wonderful Drew Doughty card from before that we stepped through, made out of thin air, Mr. Beast, Drew Doughty, defensive beast. We're going to take that and we're going to instead render a whole ton of Drews, although maybe even other players, who knows, by sending it from a Vercel endpoint. So think of this as kind of like a hello world to sending data via Vercel. So what do I mean? We're going to use lit element as we did before, right? Lit.dev, and specifically, if we look through the tutorials, there we go. Oh, map. I want the word map. We're going to go through a map, and we're going to print a whole bunch of Drews onto the screen. Built-in directives map. There we go. So a map lets you go through items in lit element and stamp out based on the array. So we're going to use type array in this case. So I'm not going to use the built-in directive. Here is what we're going to do. We're going to go, I've got Drew up, I've got here locally, and all I'm going to do, I already did npm install after I cloned it. So you're going to want to fork it, clone it, same feedback loop we're always going through here. So I'm going to do npm start first and just see we've got Drew. Cool. So the thing we're actually doing is we're making another element that's like athlete list or team roster or something like that. And then team roster's entire job is to loop through and print out as many beast modes as it finds. So before we get into the Vercel side of that, I always start this way. So we're going to have to load off of just a static JSON file. So I'm going to make roster.json. Now, roster.json, and you'll have access to the code. I'm not going to ask you to write all these JSON blobs. The roster.json is an array, so it's just a JSON object. This is a JavaScript object notation. It's the way of taking the object and storing it so we can send this data back and forth from a static format on the server, or static file in this case, and our front-end web application. So I'm making an array with an object, and what I'm going to do is look at the API that I have in my lit element, this element on the front end, right? And we're going to, this part specifically, around the initials, right? So I'm going to just mirror what this is to simplify things a bit. So obviously that's going to be bricked here because this is not valid JSON, so I'm write image. Image is going to have to come from somewhere. That is a little horrifying. Let's see what this links to. Okay, good. It doesn't link to anything. Every now and then, Copilot, NHL, LA Kings roster. Let's see if this is what it was attempting to send me to as far as photos, right? And so Drew's got to be down here somewhere. There's Drew. Oh, Drew, you're just such a lovely man. All right, so we're going to copy the image address on Drew. All right, so there's Drew. I'm not sure why it auto-completed that, but go that. So we're going to, in this case, we're going to link from a remote source instead of including the file with us for these purposes. So I got the image, name is going to be Drew Doughty, position is going to be defensive beast, stats label already calculated that's what I'm going to do, and the word top. Yes, thank you. Crazy Copilot. All right, so I now have a JSON or a JavaScript object here, right? So this is an object with properties like image, name, position, stats label, top. We're just going to have one item in this array. So it's an object inside of an array, thinking a listing of stuff. Roster.json. So the next step is I'm going to go into source and make a new file called team-roster.js. Much like Drew card, right, team roster, I'm going to have that. Let's see. Oh. Export class team roster. That is exactly what I would have written. That's a reasonable assumption of what I would have written. It's not what I was going to write, but that's fine. I still just kind of am amazed at what Copilot throws together sometimes. All right, so, and other times Atlas does not throw together. So we've got a wrapper here. We're going to take this. It's going to be called host. It's going to be display block. And then I'm going to have some type of wrapper. Yep, do that. Width 400, sure. Display inline flex, whatever. And then I'm going to have something called .item, and that's going to actually be display inline flex. Here we're going to use this display flex, so I'm going to change that from width 400. But we'll leave that wrapper on there so we can see it. And then this is not going to be all of these things, although it could be. I guess it could be team name. That's fine. All right, so we'll go with team instead of team name. I'm going to do static get tag. Tag is going to return team roster. Now the bottom, we do custom elements. Fine. It really speeds things up. Okay. Players and team there. We've got styles. We need to actually render something. So we're going to have a render. And render is going to return. That's, yeah. It's literally what I was going to write. That's kind of insane. So let's have a conversation about that. It made wide sweeping assumptions that I was going to have something that's a wrapper that is just a container for these items, which is exactly what it is. And then I was going to have another wrapper, an item. And what it did is it wrote a map. So this dot players, right, which relates to properties. Actually, let's put in a constructor too. So, and the default team is going to be the LA Kings. Big Clippers. So we have to say there is an array. It is empty. And this is the way of saying that this value is an array. So we are saying that this player's property is type array. It's got no values to start. The team is going to be LA Kings. And I should probably, for no reason, we'll just print the LA Kings part. Whoops. I didn't like Copilot. Yeah, I didn't like Copilot good stuff. There we go. It's that team. Okay. So that'll print the team out. I've got my roster. And then what we've got here is a pretty reasonable implementation of how the map works. So a map is going to step through the array. And imagine if it's an array of objects, it's going to give me access to each one of those items in the array as an object. In this case, it's going to be player. So think of this as almost like a for each loop or for item, whatever way helps you conceive of it. But we're basically going to step through the list because a map in JavaScript is going to step through each of the items and do a thing with the item being passed in. So player, player name, player.position, top stats label, and image. And is that everything? We got name, position, stats label, top, and image. Excellent. Okay. So imagine we have an array of players, right? Because it's not about just rendering one Drew Doughty. It might be about rendering 3 of them. We'll save roster. And now team roster, if its players data gets updated, is going to then play through, and you're going to see what the roster of the players is. Now, I also need to make sure I import my Drew card in this case. It's going to be in the same folder. If it's in the same folder, I want it to be / in this case. Now, I want you to actually import your other one. So imagine like your card list example. You could basically take card list as you have it and apply what you're seeing in this video to that. That's kind of the point of this to get started. So we've got team, we've got Drew card here. Okay, that looks pretty reasonable. Now this is, unlike the first example we went through in class, this is wiring things directly into another element. So this is taking those props and drilling them down. Imagine we've got team roster on the page, team roster unpacks, it goes, hey, here's my data, and then it writes a whole bunch of Drew cards on its behalf. So I'm going to save that. And then in my index, I'll still leave those buttons and things, but what we're going to do is we are going to make a script type equals module. Whoops, it's not going to point to Drew card. And in here, but again, now we're at the index, the demo. We're going to do import /src true card. Awesome. But now we're also going to import CSS. This team roster.js. All right, so we've imported the definition of Drew card and team roster. And now I'm just going to put team roster on the interface. Now it shouldn't do anything. I'm doing all of this work without actually loading. We see we have the LA Kings there, right? And if I inspect this page, we'll see we've got our team roster, which has a shadow root, which has an H2 and the LA Kings, but there's nothing in here as far as data. So one way to do initial testing with this would be to take this roster.json. I'm going to copy the contents of it and go to team roster, and I'm going to set that as the default value for players. So this is representative of 3 different players in this case, so that now the roster is going to render those 3 things. So to see this relationship just on the initial thing here, right, and say beast mode, and then that updates and I get that feedback loop of this is saying beast mode. So I highly recommend this type of a feedback loop. We're going to render a whole bunch of it. What's the thing in the name, or the name of the thing? Oh, okay, it's the roster, or it could be like landscaping businesses or business cards or card list or whatever your thing is. This is still, we haven't quite got into project 2 as far as the semantics of it, right? I want you to practice this while we're doing the other exercise about the naming conventions and things. So it's the exact same type of a process, repeated over again. So as I modify these values, or if they don't exist, for example, if there's no top, it's going to go through and print, and it's not throwing an error, I hope. Let's make sure. Nope, there's no error being thrown there for that value not existing. So I could modify these and go and look up other NHL players, right, so that we could change the image, but we'll, because it's me, we're just going to mess with some of these so that we can see that it does in fact modify each time. All right, so the instances of these are different. Now, what we're going to do is not going to load that from players anymore. All right, so now my roster is empty at the top. I'm going to paste that back in here so I modified it. Now we need to get this data from roster.json and populate team roster. So a couple different ways we could do that, but this is the easiest by far. I'm just going to call this dot update roster, and then I'm going to write a update roster, which is this dot players. I want to see what it's about to write. No, I'm not going to actually put in. Okay, so we're going to fetch a new URL, and the new URL is going to be dot, or actually it's in /assets /roster.json. Right, so the reason I knew that is the way that the new URL pattern works is it's forming a URL relative to where this file loads. Right, so team roster is in SRC in this case, and it needs to go back through the directory tree over to assets and then to roster.json. So if we do that, we'll do .ref, okay, put that method off. Let's just refresh and inspect and see what happens. So now what we're doing, I'm right-clicked to inspect, and I go to network. And under network, when I refresh, I want you to look at fetch. And if it's actually bothering to run that fetch, we can see roster.json. We can see that it used a get request method to obtain the information, and I can hit preview, and I can actually step through the data that came across. I can also hit response, and I get the raw data, right? So I can just see this is the way it's formatted coming from the file. But the preview is, this is the data that was obtained because I did a fetch for JSON-based data. And this is the way that we can then remote load or have a server end up delivering what that data is to print information on the front end. This will be the key basis for your search capability. You put in a search term, it hits some URL, the URL is going to return data in this format, and then your front end asset is going to render on its behalf. So now I need to actually wire up a roster so that it doesn't just load it there. So this, oops, sorry. I'm going to do async wait, then and we're just going to turn data. So the code for this will be available in the expand so you can see the whole thing. But what this is going to end up doing is I could do const data equals, and we should be able to console.log data now. So reading this, I've made an asynchronous function. And if I make a method or function asynchronous, it means that I can use this await. Now, await is important. I mentioned it earlier in the semester for things where you're not sure when it's going to finish. This in JavaScript is called a promise object. So fetch, the return thing from fetch, if I hover over it, it says is a promise, meaning I don't actually know when it's going to complete. But when it does complete, do this thing. Generally speaking, we don't have large chains of async awaits because then we have to keep awaiting and awaiting and awaiting. And that's something that could actually lock the DOM. So there's another way that I could present this, but just to get started, let's do it this way and see what happens. So async await, fetch this new information, then go through the response and treat it as JSON, then return the data of that response. And I actually don't even think I need this last piece. Let's see. So I've got my site up here. Now I'm going to go to console. And because I did console.log, that data that was in the file now is in a JavaScript variable inside of my method. All right, so writing this another way, probably more common, would be like address. And here we'd have const address equals. Right, so we've got a variable for address, and then we're fetching the address. Then I'll write this again a little bit more verbose so we can just be aware of what's going on there. Another common thing would be if response OK, implying that we got a valid response, then treat it as JSON. Otherwise, we return nothing. Would be another potential way of handling this. In this case, I'm going to return an empty array. This way, my program doesn't fail if, for whatever reason, I hit the wrong address, or if the server's down or something like that. All right, so now let's take off that await, because what we could do instead of async await is I can do another .then. So we're going to say get this data, and then the data is just going to be set to players, and I had a good sense that it was going to do that. So no matter when this runs, right, because JavaScript's this event loop, it's running and running and running and running. It's going to go to this, it's going to kick off this other thread, and this other thread is going to do its little processing, and then when it finishes, this other event loop is still going, and it's going to be, oh, hey, players is updated. And then this .players is going to be set to the data that came across. So save. Now we've got that data loading and updated instantly. This is the feedback loop that makes working with Vercel and micro front-end web development so powerful. I've got the state management, it's super small with lit. And if I've got my data typed correctly and I get data from somewhere else in JSON format, it's just going to automatically update and re-render. Right? So now, if I want to update the number of Druids that I have, I save this file, now I've got a zillion Druids in here. Right? This is how you're able to make searchable lists. Imagine this is not a static file, it's coming from an endpoint, which is the part we can do next. So now that I've got this prototyped out and I know that it works, hitting that path, we're going to tap into a pretty awesome capability of Vercel. And so I'm going to make a new folder in DrewCard. There we go. And it's just going to be called API. In an API, I'm going to make a new file. And that file is going to be called roster.js. Now, I'm going to lift code from one of the examples that we go over in class, and then I can reverse engineer it for you. So we're going to not use DrewCard. We're going to use IST Vercel demo, where I've already written a couple of these, which we'll step through in class. So let's see what weather does. Okay, so I'm going to that, and then we'll refactor this a little bit. So I'm going to get rid of this. We're not actually going to have a query at the moment. And we're not going to have a URL. And we're not going to have that. I actually just want this piece. Okay. And we'll just send back roster. And then here we are going to do const roster equals copy beast mode here. So const roster equals all that data. So this might seem a little weird, but instead of delivering from a JSON file, I'm going to deliver from a .js file. And the reason is what's actually happening as part of the Vercel magic, and this is, in my opinion, vanilla-ish, which is why I will bother to adopt it, even though I'm generally against reliance on infrastructure you do not have total end-to-end control over. But the magic secret sauce with Vercel in this case is any .js file you put in this API folder, it is going to automatically spin up a Lambda at the path of /API/roster. And the response is going to be whatever we see here. And while I'm just returning just a generic JSON response, it could be anything. There could be any amount of processing on the server side that needs to happen. You could connect to database servers and load this data. You could connect to Wikipedia, parse the results, turn it into this API response for a roster, and load that information off of there. I'll just keep going through some examples and some past work till we get the idea. But the idea is with the project, this is what's going to return that data to the front end. And we're going to use a search term to filter our array on the back end. This is Node.js backend code. Think of separation of concerns. Everything in the API directory is the backend microservice. The web components form the front end. And together, we get the micro front end. That this thing can ship by itself as a standalone piece with the front end and back end coupled together loosely in this regard. And we're building out the API on the back end, and we're building out the visual side on the front end. This is up until maybe 5 years ago, a pretty radical way of going about doing things. And it was definitely much more like, hey, wouldn't it be neat if? And now you're starting to really see these things come out in the wild, particularly as a result of platforms like Vercel. So let's get this to actually work. It doesn't just magically work. So the first thing we need to do next is I need to point to. I can't point to my roster.json anymore. So I'm going to point to I'm going to point to ./API/roster. I might need to debug this a little bit back and forth to get this part to work. But so at first, when we hit /roster, we see nothing came back. However, because I have the fallback of saying, hey, this value should just be, nothing if it fails, we're still okay here. So, right, it's returning, and I don't actually need to store the data, just go and do the fetch. It's returning the response is nothing, and then it's still just going to print nothing in this case. So to attempt to make this work, we need to start another server. And this will, unfortunately, be a little bit more of a confusing aspect of this, which is why I'm recording it. I actually have 2 servers running at the same time in this repository. The first server is going to go and do the front end. The second server is the back end side of it. And it loaded from there. When I do it on the pure front end side, I will probably get an error of some kind. In fact, if we look at the network, see this is hitting API/roster, and there's nothing there. And this is very silly. I have way more advanced ways of solving this in my own projects, but it's because localhost 8000, which is this port, and 3000, which is this port, aren't really allowed to talk to each other. And why this is obnoxious, unfortunately, is for Vercel to operate, it must compile the application end to end. That means compiling the front end. That means running npm run build. That's why your stuff works when it goes out the door. And then the back end, it basically has the same thing. So what I can do now is I can modify roster.js. We'll take out this from roster.js, save. And on port 8000, it still doesn't do anything. But on port 3000, when I refresh, it actually makes the call and loads these new Druze. So when I inspect and I hit network and we see it again, it's requesting roster. Roster's coming back with that information. But the critical difference is a server just fired there, processed, and then gave us back roster. Subtle difference at first, but we can do infinitely more complex things because the front end doesn't know that that's a server. The front end is just loading JSON data for all it cares. So we can start modifying the back end and still have our front end sit there and load those difference in assets. So now that this is working, and it's a critical, right? That's why I wanted to point out there's this two-step. This part is live updated front end assets, the web component side. This part is actually running a compiled version of it. So if I were to make changes to the CSS in here, I would have to actually go shut down the Vercel server and run Vercel dev again, and it's going to compile to get the change in place. The back end, though, I'm going to be able to just keep modifying that and see. All right, you can see a whole bunch of interesting little questions there. So let's see if this works when it's on production, because honestly, I haven't done that live and before. So you do git add a, git commit, git commit, team roster push main. All right, now let's go up to Vercel. And I've got Drew card just now. And we've got the build log. Oh. It's running. Let's see. Duration 11 seconds. No, that was 29 minutes ago. Log, functions, deployments. Nope, Drew card. It says ready as of 14 seconds ago. So let's see. So now when I go to Drew card Vercel app, I'd have to do a Control-Shift-R. Boom. That's awesome. So when I hit network and we inspect, we see that there is drewcard.vercel.app/API/roster. And now if I actually go to that path, and I have to, again, I have to get comfortable with the idea of Control-Shift-R. That is a super refresh. It makes Chrome ignore cache header settings. And the reason why I need to get comfortable with that is these Vercel endpoints implement a type of caching that is fantastic. It's extremely fast. Imagine what I just deployed if this had to go and connect to a database and it had to return what today's weather is or what the date is, or Wordle, it needed to get the word of the day and compare it against a list of every word that exists. And if that last one sounded a little specific, it's because students in my class made it last semester. But it is also effectively how Wordle works, because the Wordle game on New York Times is a web component, and it's connecting to a backend to do that work. So there's 1,000 people that hit this website at the same time. Vercel on the very first call is going to request this path. It's fresh data. So it processes and runs all the stuff and then returns the JSON to you. But the next 999 of you are getting the cached output. It's never actually running that Lambda again. So it's as if it goes through their cache wall because it's not hit, runs Lambda, comes back, and then leaves a trace of it in their cache grid so that then everyone else's request hit that cache data and get an instant response instead of running a server. It is extremely efficient and pretty much infinite scaling. So that is where I want you to come in. I want you to take this and apply this same type of approach to get data to render through your card. You're going to have to modify the fields from what I put in because your cards are different, but you should be able to heavily base your code on what I have here. And the reason we're going to do it using yours at first is because this is the exact same feedback loop that we're going to use in project 2. So when we want a listing of badges, we're going to type in a search term, hit go. It's going to send a message to a Vercel endpoint with the search term, filter out a list, and we'll just predefine the list or whatever, and then return it to the front end and render it. So we'll have to come up with what the API is for that second scenario, but we already kind of have some API work on this side. So I hope this is helpful. If you have questions, particularly about Vercel and getting this stuff going, just go ahead and let me know on the Discords.